So let's look at these two functions here. Y equals 3, the sine of 3 times x minus pi over 3, and the sine of pi over 3, x minus 2 pi over 3. Okay? So on this one, what's all going on here? Well, we graph it out here quick. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Pi over 2, pi. 3 pi over 2, 2 pi. 1, 2, 3, negative 1, negative 2, negative 3. All right. Where do we start? Y equals sine of x. Ooh, supposed to be red. Try this again. Y equals sine of x, which is 0, 1, 0, negative 1, 0. Easy peasy lemon squeezy. I think everybody gets that. What does the 3 do to this? Or the sine of 3x. What does that 3 do to it? Squishes it. How much? Everything's 3 times skinnier. 3 times skinnier. So instead of going 6 spaces, it is 2 spaces. Okay? Instead of 12, we're 4. So boom, 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 boom. And then minus pi over 3. Pi over 3 is how many spaces? 4 spaces, because 1/3 of 12 is 4. So everything moves 4 spaces to the right. Look good? Okay. This one. Ooh. That one's a little different. Mr. Hawks, how is that different? There's a pi over 3 in front of the x, and look at where everything is positioned here and where everything is positioned here. Do you see another slight difference? Shanty, can you help him out with that one? What's different about this one and this one? There we go. That's why I called on you, Shanty, because you're very observant. We got the pi over 3 inside parentheses. So could I rewrite this as pi over 3 on the outside of parentheses? Then what would be on the inside of parentheses? X minus 2. Okay, so this is our b, right? Deals with our period. What's 2 pi divided by pi over 3? Well, that's a complex fraction, isn't it? So it's 2 pi times 3 over pi. Because you multiply by the reciprocal, what happens to our pi's? It's normal 6. What's our axis all the time so far has been things with pi's. What's a normal 6 doing there? And look, there's a normal 2 there. So when you have a pi over something or pi out in front to deal with periods, when you make your graph, it's going to be totally different. You're going to go 1, 2, 3, 4, 5, 6 to get to like, let's make that 3. 1, 2, 3, 4, 5, 6 makes 6. 1, 2, 3, 4, 5, 6 makes 9. 1, 2, 3, 4, 5, 6 makes 12. Okay. All right. So when you have one of these, instead of graphing sine of x first, we're going to graph sine of pi over 3x. Well, how long should pi over 3x last? It should end at 6. So sine ends up here and it starts here. And halfway in between on a sine curve is also on the x-axis, right? So halfway in between these two, that should go up to 1, and halfway in between, it should go down. So this is the sine of pi over 3x, like that. Okay? Then, the final answer should be this. What's minus 2 do to it? Moves it to the right. How far? 2, which is how many squares? 4 squares to the right. Because I made 3 6 squares, so I've made 2 squares for every number. So 4 squares to the right. 1, 1, 2, 3, 4. 1, 2, 3, 4. Looks like that. Are we good? Okay, so when you have a pi involved, it makes it a little different looking. Okay, we're going to do 1. No, are we doing? Yeah, nah. Are you guys good with this? You want just your homework problems, or should I do one more? There's only one of these on your homework. So are we good? Okay. Page 217 or page 127. We're going to do 19, 21, 23, and 26. 4 more problems. Okay? And if you have questions, I'm around. I can help you on them. Okay? There you go.